most important natural resources.
It underpins human food production systems,
supports the cultivation of vegetation for feed, fiber, and fuel,
and has the potential to help combat and mitigate climate change.
It's also a rich and complex ecosystem,
accommodating a staggering array of biodiversity.
Therefore, the importance of soil on life is vast. Franklin D. Roosevelt once said,
"The nation that destroys its soils, destroy itself."
He wasn't wrong.
Healthy soil is crucial for human life and well-being.
However, soils across the globe are being threatened and damaged by human activities.
In this video, together with the group,
we will be discussing about the importance of the soil,
The relationship between humans and soil,
and important things you should know about.
Soil chemistry is one of the three critical aspects of soil health. The chemical composition of a soil depends on the materials from which they were formed and the processes of formation. The chemistry of the soil will influence the supply of nutrients required for plant growth and production. It also serves as the key in sustaining life, affecting air and water quality, the growth of plants and crops, and the health of the entire planet. Soil chemistry is a branch of soil science that deals with the chemical composition, chemical reactions, and chemical properties in soils. The discipline of soil chemistry has traditionally focused on abiotic transformation of soil constituents, such as changes in oxidation state of elements and association of ions with surfaces. Chemical reactions in soils often lead to changes between solid, liquid, and gas states that dramatically influence the availability of chemicals for plant uptake and leachate out of the soil, which are important aspects of fate and transport of nutrients and contaminants in the environment. With the ever increasing pressures humans are placing on soil resources, detailed knowledge and understanding of soil processes is imperative. Modern soil chemistry strives to understand interactions between different soil processes, such as interactions of soil microbes and soil minerals.
Soil is one of the Earth's life-sustaining components. It serves as a physical support, a source of water and nutrients, and a medium in which materials are recycled for future generations of all living things. Technically, soil is defined as the unconsolidated material on the surface of the earth that shows evidence of life. It is composed of inorganic and organic materials, water, and air. The soil is defined as the organic and inorganic materials of the earth's surface, which provides a medium for the growth of the plants. It slowly develops over time and is composed of various different materials, and it varies due to its composition and structure. It is important for the sustainability of an ecosystem as it serves as a natural medium for vegetation and growth. Soil comes under non-renewable resources, and its formation is a very slow process.
The first type of soil is sand soil. It is also known as light soil. Sand is the largest of the mineral particles that creates large pore spaces that helps improve aeration. Generally, sandy soil is composed of 35% sand and less than 15% of silt and clay. Primarily, sand is the smallest pieces of eroded rocks with a gritty texture. In a sandy soil, most of the soil particulars are bigger than 2 millimeters in diameter. Sandy soils are considered as one of the poorest types of soil for growing plants because it lacks the ability to hold nutrients. It is also not fertile and it has poor water holding capacity, which makes it hard for the plant's roots to absorb water. This type of soil is very good for the drainage system since water flows through the large pore spaces quickly. This type of soil is usually formed by the breakdown or fragmentation of rocks like granite, limestone, and quartz. Sandy soil has numerous uses in different sectors. It is used in agricultural needs, which is applicable to potatoes, carrots, lettuce, and many more. It is also used in water purification, easy drainage, construction, foundation, frictional properties, changing pH, and many more.
The next type of soil is the silt soil. Unlike sandy soil, silty soil is smaller in size, smoother, and surface-like when moistened. It is made up of rock and other mineral particles which are smaller than sand and larger than clay. It has the smooth and fine quality of the soil that holds water better than sand. When it is rolled between our fingers, it leaves dirt on our skin. Silk is easily transported by moving currents, and it is mainly found near the river, lakes, and other water bodies. The silt soil is more fertile compared to the other three types of soil. Therefore, it is also used in agricultural practices to improve soil fertility. Even though this soil is fertile, it can hold as many nutrients, but it can retain water for a longer period of time. It is cold in nature because of its moisture retention quality, and also it can get compacted easily. This type of soil is commonly used in agricultural since it is good for growing crops because it promotes water retention and air circulation.
Clay soil. Clay is the smallest particle among the other four types of soil. There is extremely little or no airspace since the particles are so closely packed. As a result, water is efficiently retained by this property. This soil has very good water storage qualities and makes it hard for moisture and air to penetrate into it. It is very sticky to the touch when wet, but smooth when dried. Clay is the densest and heaviest type of soil which does not drain well or provide space for plant roots to flourish. The particles of clay soil are compact in nature. Hence, it tends to not hold enough air, which is the basic requirement of many plants. Hence, not all plants can be grown using clay soil. However, some plants can be grown using clay soil such as apples, ash, willow, aster, and many other plants. These plants can grow themselves in clay soil because of the moisture that it contains.
Now, let's move on to the next type of soil. Loam is the fourth type of soil. It is a combination of three materials like silt, clay, plus humus and sand, which are ballast present in this soil. For instance, it has the ability to retain moisture and nutrients. Hence, it is more suitable for farming. This soil is also referred to as agricultural soil, as it includes an equilibrium of all three types of soil materials being sandy, clay, and silt, and it also happens to have humus. Apart from this, it also has higher calcium and pH levels because of its inorganic residues. These soil are fertile, easy to work with, and provide good drainage. Depending on their predominant composition, they can be either sandy or clay loam. As the soils are a perfect balance of soil particles, they are considered to be a gardener's best friend, but still benefit from topping up with additional organic matter. The color of this soil is dark and it is dry and crumbles when touched. Between the soil particles, the air moves freely down to the roots. This soil supports almost all types of fruit and vegetable crops.
Soil pollutants under sources. Soil pollution is defined as the presence of toxic chemicals such as pollutants and contaminants in soil in high enough concentrations to pose a risk to human health and or the ecosystem. In the case of contaminants which occur naturally in soil, even if their levels are not high enough to pose a risk, Soil pollution is still said to occur if the levels of the contaminants in soil exceed the levels that should naturally be present. Some of the most hazardous soil pollutants are xenobiotics, substances that are not naturally found in nature and are synthesized by human beings.
Soil pollution is caused by the presence of man-made chemicals or other alteration in the natural soil environment. This type of contamination typically arises from the rupture of underground storage links, application of pesticides, percolation of contaminated surface water to subsurface strata, oil and fuel dumping, leaching of waste from landfills or direct discharge of industrial waste to the soil. Moreover, the most common chemicals involved are petroleum hydrocarbons, solvents, pesticides, lead, and other heavy metals. This occurrence of this phenomenon is correlated with the degree of industrialization and intensities of chemical usage.
A soil pollutant is any factor which deteriorates the quality, texture, and mineral content of the soil or which disturbs the biological balance of the organisms in the soil. The main pollutants of the soil are the biological agents and some of the human activities. Soil contaminants are all products of soil pollutants that contaminate the soil. Human activities that pollute the soil range from agricultural practices that infest the crops with pesticide chemicals to urban or industrial waste or radioactive emissions that contaminate the soil with various toxic substances. Pollution in the soil has adverse effects on plant growth. Pollution in soil is associated with biological agents, agricultural practices, radioactive pollutants, urban waste, and industrial waste.
Biological agent. Biological agents works inside the soil to introduce manures and digested sludge into the soil. Biological agents includes bacteria, viruses, fungi, other microorganisms, and their associated toxins. They have the ability to adversely affect nutrients from the soil. The organic components of soil serves as cementing agents, return nutrients to the plants. Allow soils to store moisture, make soil tillable for farming, and produce energy for soil microorganisms. The presence of living organisms greatly affects soil formation and structure. Animals and microorganisms can produce pores and crevices. Plants' roots can penetrate into crevices to produce more fragmentation. Plant secretion promotes the development of microorganisms around the root and an area known as the rhizosphere. Additionally, leaves and other material that fall from plants decompose and contribute to soil composition.
The soil of the crops is polluted to a large extent with pesticides, fertilizers, herbicides, slurry, debris, and manure. Soil pollution can be a result of poor agricultural practices. Unsustainable agricultural practices reduce soil organic matter, compromising soil's capacity to degrade organic pollutants. This increases the risk of the pollutants being released into the environment. Some agricultural practices, including indiscriminate use of pesticides, insecticides, and herbicides, is one of the reasons why there is soil pollution. Pesticides not only bring toxic effects to humans and animals, but also decrease the fertility of the soil. Some of the pesticides are quite stable, and biodegradation may take weeks and even months. Pesticide problems such as resistance, resurgence, and health effects have caused scientists to seek alternatives. Pheromones, and hormones to attract or repel insects, and using natural enemies or sterilization by radiation have been suggested.
Radioactive pollution. Radioactive pollution is defined as the increase in natural background radiation emerging from the activities of man using naturally occurring or artificially produced radioactive materials. Radioactive materials released into the environment can cause air, water, surfaces, soil, plants, buildings, people, or animals to become contaminated. Radioactive substances such as radium, thorium infiltrate the soil and create toxic effects. Improper disposal of radioactive waste can severely contaminate the soil and result in soil pollution. The radioactive matter present in this type of waste may mix with the components of the soil, rendering it highly toxic and infertile. Furthermore, any plants grown in such soils may absorb the radiation present in the soil and accumulate it within the bodies. This radiation may make its way up the food chain when herbivores consume these plants and carnivores consume those herbivores.
Generally, urban waste includes garbage, domestic refuse, and discarded solid materials such as those from commercial, industrial, and agricultural operations. They contain increasing amounts of paper, plastics, glass, packaging materials, and toxic or otherwise hazardous substances. Since a significant amount of urban waste tends to be paper, food waste, the majority is recyclable or biodegradable in landfills. The portion of solid waste that is hazardous such as oils, battery metals, heavy metals from smelting industries, and organic solvents are the ones we have to pay particular attention to. These can, in the long run, get deposited to the soil of the surrounding area and pollute them by altering their chemical and biological properties. More than 90% of hazardous waste is produced by chemical, petroleum, and metal-related industries, and small businesses such as dry cleaners and gas stations contribute as well. Urban waste also increases microbial activities, microbial decomposition of organic waste that generate large quantities of methane. Besides, many chemicals to pollute the soil and water flowing on its surface.
And now we move on into industrial waste. Industrial waste have different amount of toxic contents in hazardous chemicals, such that when they deposited in soil, they affect the layer strength in the topsoil, thus reducing the soil fertility and biological activity of the soil. In addition to that, a hazardous effect leads to ecological imbalance, thus making troubles in crop production. Apart from that, it may cause severe health problems for those who are consuming such crops because soil and crops are contaminated by toxic chemicals and hazardous materials. The main sources of soil pollution from industrial sources includes mining and quarrying, manufacturing, energy production, construction facilities, transportation, and many more. The discharge of industrial waste into soils can result in chlorinated industrial solvents and produce dioxins from the manufacture of pesticide and the initiation of waste and plasticizers or dispersants.
Soil quality is an effective tool for monitoring soil function. Assessing soil quality involves measuring physical, chemical, and biological soil properties. In using these measured values to identify properties of the soil that may be inhibiting soil function, or to monitor how changes in management are affecting soil functions. The essential steps on this assessment are to identify the management goals, for example, food or fiber production, environmental protection, and to determine the soil function that contributes toward accomplishing them. For food production, functions such as providing a suitable plant, substrate, and serving as a nutrient reservoir are important. For a soil managed for environmental protection, key function are storage and purification of water and interaction with the atmosphere.
In summary, soil is important for a variety of reasons. It is the foundation of terrestrial ecosystems, providing essential nutrients and water to plants and serving as a habitat for a diverse array of microorganisms. Soil also plays a vital role in regulating the Earth's carbon cycle, as it stores and releases carbon in the form of organic matter. The chemical makeup of soil can have significant effects on the growth and health of plants and the overall productivity of ecosystems. Soil chemistry, on the other hand, of course, we all know this, is influenced by factors such as pH, nutrient availability, and the presence of toxic elements, which can impact plant growth and the health of the ecosystem. Ensuring the chemical health of soil is therefore important for the sustainable management of our environment. This is Group 2. Thank you so much for tuning in and for reaching the end of today's video. Till next time, bye!